All right, here's our objective. We want to use the Coulomb's equation for solving for electrostatic force. All right. This video is going to be a little different in that I'm going to just write stuff down on paper. That's not typically what I do. And here's where you're going to put the formula. Here's where you're going to put the variables, what they stand for. I'll write it all down in a second. I'd get one of these visuals and I'd get the solution to it on your note sheet. All right. So electrostatic force, the force is or rather the formula is Q1 times Q2 divided by R squared. F stands for electrostatic force. K is a constant, and it's always equal to 9.0 e to the 9th newtons times meters squared coulombs Q squared. Q1 and Q2, those are my charges. Their units are C for coulombs, and R stands for radius or distance, and that's in meters. All right? And we're going to apply this, the four-step format, to this problem. We're going to solve for Q. So we should get an answer of 720. All right? The four-step format is info. F is equal to X. All right? My Q1 and my Q2, they're right here. My charge is 9 microcoulombs and 8 microcoulombs. My distance, or my radius, is 3 centimeters. And I'd convert that to meters, and I get 0.03 meters. All right? Now, I'm going to shift to this view, because now I can plug things in, or I'm going to put my formula down. All right? There's my formula. This goes here, this goes there, and that goes there. And I should tell you, MC is equal to 1 times 10 to the negative 6th. All right? Exponent. I didn't write my constant down. My constant is this big number. So now I substitute in. I get F or X, whatever you want, equals 9.0 times 10 to the 9th Newton times meter squared Coulomb squared times 9 times 10 to the negative 6 C 8 10 to the negative 6 C. This is divided by 0.03 meters squared. Okay, that's what it looks like. All right. Now I'm going to move into solving it. All right, this whole thing. You can use a calculator. All right. I'm going to just show you a couple tricks, applied tricks to help. I think it makes it easier and quicker. All right, the first thing is we got a lot of numbers with exponents. You can see an exponent there, there, and there. All right. What this says is when their exponents are with exponents, add when they are multiplied. I can't even read what I wrote. So I'm multiplying 9, 10 to the 6, negative 6, and negative 6. If I add that all up, I get times 10 to the negative third. All right. Couple of other thing, my coulombs are going to cancel, and I'm left with newtons times meters. All right. And then I can do these things separately. 9 times 9 times 8. So that's 81 times 8. All right? All over 0.03 meters squared. Okay? Now, I can do either of these things first. I can take care of that, or I can take care of this first. All right? And it doesn't matter. So 8 times 8 is 64. Add a 0. So 8 times 80 is 640 plus 1. Oh, I made a... No, that's right. 648. Let's check that on a calculator. 9 times 8 times 9, 648. So 648 times 10 to the negative third Newton meters all over 0.03 meters squared. Okay? Now, I got to take care of this thing. I'm going to finish it right here on this piece of paper. 0.30 squared is the same thing as, like, I could just multiply 3 times 3. That equals 9. And I would have to move the decimal spots twice in each number. So I'd move the decimal spots 4 spots to the left. I forgot that squared. Now, these would cancel, and I'm left with this thing. All right? Now, I can plug this into a calculator right now. 648 times 648 second log to the negative third equals that divided by 0.0009. 720. Okay, that's what I should get. Now I'm going to show you another trick. I'm going to write this in scientific notation. 1, 2, 3, 4. All right? So that's 9 times 10 to the negative fourth. All right? Now here, before, with exponents, when you multiply them, you add them. When you divide exponents, you subtract. So negative 3 minus a negative 4 is 1. Positive 1, because this becomes positive. This is negative 3 plus 4, and that equals 1. Okay? So this reduces to 648 divided by 9 times 10 to the 1. Now this is just times 10, all right? So I would divide 9 into 648 and then multiply it by 10. So 648 divided by 9, all right? Now, what I could do is 70, like this is going to be 72. I just looked on the calculator. Times 10 to the 1 equals 720 newtons. Now, it's positive. That means this is an attractive force.